Chapter 1 Fundamentals of Thermodynamics. Section 1.4 The Second Law of Thermodynamics. It states that the entropy of an isolated system always increases until it reaches maximum. Because the universe is viewed as an isolated system, we say the entropy of the universe always increases until it reaches the maximum. What's entropy? The simplest definition of entropy is the measure of the dispersal of energy. There are many alternative expressions of the second law. For example, heat cannot flow from a lower temperature object to a higher temperature object spontaneously. Another expression is this: a heat engine that converts heat to work cannot achieve 100% efficiency. There are more different expressions in terms of thermodynamic properties: Gibbs energy, Helmholtz energy, internal energy, and enthalpy. For example, the Gibbs energy of a system always decreases until it reaches minimum under the constant temperature and pressure condition. We need to pay attention to the condition now. The Helmholtz energy of a system always decreases until it reaches minimum under constant temperature and volume condition. We can also use the internal energy and enthalpy of the system as the criteria for determining whether a reaction will proceed spontaneously or not. For example, the internal energy U of a system always decreases until it reaches the minimum under the constant entropy and volume condition. What about enthalpy? The enthalpy of a system always decreases until it reaches the minimum under the constant entropy and pressure condition. Again, we can use G, A, U, or H as the criteria for determining if a reaction or a physical change can proceed spontaneously, but we need to pay attention to the conditions. If you use G, it's gotta be constant temperature and pressure condition. If you want to use A, it's got to be the constant temperature and volume condition. If you want to use U, it has to be constant entropy and volume condition. If you want to use H, it has to be constant entropy and pressure condition. So we can eventually prove all those statements are equivalent to each other. But in the end, we just need to remember the essence of entropy first. It's the measure of the dispersal of energy. And number two, we just need to remember the original form of the second law of thermodynamics. The entropy of an isolated system always increases until it reaches maximum.